This is the physics first lesson, chapter 3. This will be an introduction to vectors. And let's dive right in here. So when we get to using our calculators, it's important that you put your calculator in degree mode and not have your page fly off like that. So in degree mode, like here. So on your calculator, you'll often see where a button might say degrees or radians or gradians, and make sure that it's not these two, or that'll mess up your calculations. That's when you're using your calculator. So a little bit of trigonometry review, or heck, teaching you if this is the first time. Take a triangle. We're focusing on this angle here, which will be labeled theta. The longest side is always the hypotenuse. The adjacent to theta is called adjacent, and the one opposite is called opposite. You just have to be careful that the hypotenuse is the longer side and adjacent is the other adjacent that isn't as long. Now, of course, there's the classic phrase SOHCAHTOA that you're taught in a math class. And that helps you learn that sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But we actually won't be using them in that form usually. If you manipulate them, you get what I have in this box here. And this is going to be a more useful version for us, in which we'll use this to solve for adjacent, this for opposite, this for theta, and this for the hypotenuse. And I have some notes here showing you. This is just an adjustment of a squared plus b squared equals c squared. This here is just an adjustment of what tangent is. And notice you don't divide by tangent. You have to take the opposite of tangent, which is this right here, to get it on the other side. And so let's take a look at a problem. Let's say that you are leaving your house here, and you're going to the supermart here. Well, typically when you're driving, you can't go in a straight line there. So as I've indicated, we go along the x-axis. Let me fix that. That doesn't look good. Let's go here. We go along this x-axis here. Or you could say east. And then we make a right turn at an intersection, and we go along the y-axis or north. And then we go along, we make a right turn again, and then we go east again until we get to the mart. And so we do it in 3 pieces, and that's typically how you drive, of course. But what I'm curious about in this problem is, what if you did it in a blimp? So in a blimp, you of course would raise above your house, and then you would just go directly there. So the question is, how far is it? And what angle would we want to set off at? So if you take my journey, I've got 2 miles here and 1 mile here. Sorry, that's a little messy, but that's a 1.0. And so if you add your 2 and your 1, you get 3 miles to the right and 4 miles going to the top. We're solving for the question mark here. And so the correct equation is hypotenuse is the square root of one side squared plus the other side squared. It doesn't really matter what order you go, and you end up getting, I was a little sloppy with my sig figs here. So let's just do this with 2 sig figs the entire time, and you get 5.0 miles, which of course is less than if you add each of these up. If you add up the driving in a car directions, then you end up with 7 miles when you add up the 3 and the 4. And so notice this is left, the direct route. Now, regarding what angle should you go at? For most problems, I'm going to say, if we look at a Cartesian axis, X and Y, I want your angle to start from the positive x-axis and go counterclockwise like this. So if we went that far, our theta right here would be 90 degrees. If we kept going, 180, and kept going, 270, and of course, if we go all the way around, 360. A problem might define things different. They might ask, what's the angle counterclockwise from the y-axis, from the positive y? In that case, you would just say, what's the angle going that way? And so you have to pay attention to the problem, but if it doesn't say anything, then always do it the way I did it here, at least in my class. So theta is the inverse tangent of opposite over adjacent. You get 53.1, and if we keep our 2 sig figs, you end up with a 53 degrees. And what that means, again, is that would be 53 degrees going that way. Of course, you could do the math and figure out what would the angle be this way from the positive y, but there's no need to bother with that. Now make sure you practice this in your calculator. Get out your calculators and practice both of these problems, especially this one. And you'll notice on your calculator, you'll have the tangent button. And for most calculators, you'll want to hit second button and then the tangent button. And that's how you will get the inverse of tangent, as I have written here. And mess around and make sure you can figure out. Of course, if you can't, see me in class and we will help you out. So now we have the ability to work in 2 dimensions. Up until today, we've always been stuck in just 1 dimension. Now, a term to be aware of is a vector versus a scalar. A scalar is just magnitude. So an example of that would be 25 meters per second. That would be a scalar. A vector also has magnitude, but in addition, it also has direction. So an example of a vector would be 25 meters per second east. And this doesn't usually play a huge role, but it's something to be aware of. And I have some examples of vectors here and some examples of scalars here. An interesting one is time. We just always assume the direction of time is just moving forwards, and so it's not given. Moving along, some trigonometry practice I have here. I will zoom in again. This is mainly for you to practice. Take this triangle. In this case, we're solving for the opposite. So you use the equation that I gave earlier. Here we're solving for the adjacent, and I have that equation there. Practice this, make sure it works out. We'll just keep sig figs the same. In this case, the 17 is the opposite. The 23 is the adjacent. And so the question mark C is the hypotenuse, so that's the right equation. The question mark theta, right there, that angle is right here. So again, practice this in your calculator, make sure it works out. If we look down here, this one brings up an interesting situation. If when solving for this side right here, which is the opposite side, you can use either the opposite side equation, in which you have to use the prior answer, and you get 7.6, or you can use Pythagorean theorem, a squared plus b squared equals c squared, But it actually ends up giving you two different answers, because in this case, sometimes if you stop in the middle of your problem and do sig figs, it can mess things up. And that's fine. I know that happens. Of course, if that ever happens on a quiz or test and I mark you wrong, please bring it back and I will give you credit back. So how are we going to write these vectors down and keep track of it? Well, there's a few different ways. One way, graphical, that means to just make it look like as if you were drawing it on a map. So the direction of your arrow is, of course, direction, and the length of your arrow is magnitude. So a longer arrow has more magnitude. We can also do it algebraic, which is usually even better. And you can do it with two different types of graphs. You can use a Cartesian graph, our typical XY. And in this case, if we went from the origin to this point here, we could say that the X value at the end of the journey is +2 and the Y is -3. To remind you, as you go this way, that's a negative Y value. And that's what we're mainly going to do. This will be our most useful version. We'll be doing this. You can use a polar graph too, in which from the origin you have circles that radiate out. And I have an example here in which the 25 is the length of the arrow and the 45 is the angle. But we're not really going to use that in this class. I just wanted to show it because you'll probably see it in future classes, especially math. The note we can talk about later. The story as I have heard it is that Descartes came up with the Cartesian axis system when he was sick in bed, and the ceiling had tiles, which I assume were equal sizes, and he watched a fly moving around and he realized he could track the fly's movement. I have no idea if that's true, but it's an interesting story. So when adding vectors, if you do it graphical, you have to be careful how you draw your arrows. Make sure you draw your arrows accurate. Make sure you get the direction they're going accurate and the length accurate, because you're going to add them up. So in this case, if we did this journey of A plus B plus C, and you went to draw that, you would draw your A, and again, you want to draw this as accurate as you can. Then draw your B as if you did it after the A journey. And then draw your C, something like that. And then, if I asked, what is the overall journey? You would start at the beginning, and go to the end, and you'd end up drawing an arrow roughly like this. And if we just look at that arrow, it looks kind of like that. And so you could measure this arrow and compare its length to the original arrows to find out the magnitude, and the direction would just be, again, relative. I'll switch colors here to help you out, from the positive x-axis. In this case, if you do this and you compare it to what we had here, you might get a little bit different numbers, but you should be in the general area of 1.9 as compared to the other arrows, and 85 degrees starting counterclockwise from the positive x-axis. And notice I said, to do a good job, you definitely want to use a ruler, and it's a good idea to use a protractor to really do this right. And that's going to be important in tonight's homework. Otherwise, you'll find your answers might be quite a bit off from what I have. Now, I showed you can do it in any order. The order of operations doesn't matter. So, for example, if you did C and B and A, you end up with the same final vector, R here and R here. Now, R stands for what's called the resultant, or the resulting vector. And as I mentioned, theta will be counterclockwise from the x-axis. Even though you can do it in any order, I recommend you do it in the correct order just so you don't get confused. And that should take care of this lesson.